Good day. My name is Soikun from Astif UMS. The title of my presentation today is Generative Art Preliminary Exploration with Python Programming. The abstract. The article uses the Python programming language to introduce generative art as an alternative to conventional art and design. Understanding generative art in the age of AI is seen as a way forward to remain relevant. Through the use of practice-based research methodology, the article explores principles, processes, and tools for generating art through coding. Practical samples are used to demonstrate the potential of generative art through basic coding examples. This research also highlights the role of generative art in fostering interdisciplinary collaboration and transcending the boundaries of conventional art forms. Recently, the art world has been transformed by the advent of technology, especially AI and generative arts. Generative art, also known as procedural or algorithmic art, is a form of art that creates itself independently. This can take the form of mathematical functions that create geometric and precisely calculated work of art. The research question: generative art is a form of digital art that uses algorithms, often aided by computers and software, to create artwork. Rather than creating art manually through traditional techniques such as painting or sculpting, generative artists write code that defines rules, processes, and parameters to create art dynamically. This type of art often explores the relationship between human creativity and computer-generated randomness or automation. Python is a popular programming language for creating generative art due to its ease of use, extensive libraries, and vibrant community of artists and developers. The practice-based research methodology, often referred as artistic or creative research, is a valuable approach to improving our understanding of generative art and also AI. This methodology involves the creation of artistic works as a means to conduct research and can offer several benefits to the fields of generative arts. Practice-based research allows artists to explore generative art concepts through hands-on creation. The problem statements. A low understanding of scientific basis of generative AI and the arts may be the barrier to negative perception. A solid foundation of understanding the capabilities and potential of generative AI in the creative industries can help creative practitioners to achieve impressive results in various fields of art and design. A lack of true understanding and semantic coherence can hinder the realization of the true potential of generative art. Information on the limitation and at the same time address the ethical challenges that may help to unlock new borders of creativity and restructure the way art is expressed. The reference to practice-based research methodology is found in many other fields, including medicine and engineering. In the field of digital arts and computer technology, this method is rarely found. This method, often referred to as artistic or creative research, is a variable approach to improving our understanding of generative arts. The objective of this research, the goal is to give readers a straightforward introduction on two important topics, generative arts and the Python programming language. The goal is to teach readers what generative art is and how Python can be used as a creative tool to create artwork. This research shows how the Python programming language creates artwork using algorithms and also codes. It also explores the creative process behind generative arts and demonstrates the possibilities of Python. The objective is to also investigate the principles and creation of generative art using Python, focusing on practice-based research approach. Using Python as a creative tool to create generative art, a practice-based method approach will provide insights, and hands-on experience where generative artworks are actively created to better understand the intricacies of the art form is object. The significance of exploring creative application of programming language lies in the expansion of artistic possibilities and the fusion of technology with art. This article will open new frontiers for innovation, pushing boundaries into new possibilities in the art and design world. Programming languages such as Python can empower artists to experiment with unconventional form of expression. It will also contribute to interdisciplinary collaboration between programming and art and design, taking further the cross-disciplinary approach that will result in novel creations. Exploring Python will push artists and designers to uncover new uses and capabilities of programming language and contribute to the advancement of technology. Generative art, which is fascinating juncture of creativity and technology, has since acquired a reputation in the modern art world. This innovative form of artistic expression relies on algorithms and programming to create captivating visuals, often transcending the boundaries of traditional art forms. Python popularity as programming language stems from its simplicity, readability, and extensive libraries, making it an ideal choice for generative artists. Python provides various libraries and frameworks that enable the creation of generative artwork such as Pygame, Processing.py, and also Turtle Graphics. Methodology. This research adopts practice-based research. It is an accepted methodology in medicine, design, and also engineering, where it is often called action research. While it has been always present to some extent in the arts and humanities, recently artistic practice has developed into a major focus of research activity both in the product or process. The researchers will conduct the practice of the art to investigate its process or how certain approaches interact with creative process. Practice-based research usually gains insight into the process, learns more about the field of practice, understands the cognitive process of the practice, and gains insight into the practitioner. The data analysis. By utilizing the PBR method, a set of codes is written to generate the art. The codes were sources and modified from a variety of sources, including GitHub, Atomic Object, and other online resources. The Python code samples are specifically chosen for generative arts for decorative purposes. The creation of generative art in its research is using Python programming language version 3.11. The research explores different ways to achieve the desired generative artwork, such as using Python libraries, Matplotlib for basic generative art, and explores other libraries like PIL, Python Imaging Library, or NumPy to enhance the artwork. Following the practice-based research, the research attempts to explain the creation of generative arts using Python and its extensive libraries. Step-by-step process. The researcher creates generative artworks using Python and library, NumPy, and also Matplotlib. Creating a simple generative art piece may give insights into how the technology works and may lead to an understanding of AI generated content in art. The sample codes are written step by step to allow readers to understand the use of certain codes and library as well as other software. Simpler turtle codes by using Python's library. Readers can modify certain codes to come up with different results in Python. The research outcomes. The exploration of generative art in its research helped in a way to understand how computer art is produced using codes. The mixing of science and art can make computer-generated art to be more artistic, By tweaking the codes according to design elements and principles, the human touch can be added to the AI-generated image with this understanding. By focusing on the practice-based method, the process of creating the generative art can be shown and discussed with hands-on experience to reach the result. Readers can practice the following by following codes and even tweak the codes to produce different generative art results. It is also seen that using the PBR method can provide a practical and experiential understanding on how generative artwork and Python can be leveraged as a means of artistic expression. Conclusion. This article provides with practical insights and hands-on experience in the world of generative art using Python, fostering creativity and innovation in the intersection of art and technology. While it can be seen that mostly depends on codes and algorithms, the human touch and creativity can still be withheld. Artists will still depend on manual sketches and drawing while combining the ideas with codes to generate the intended ideas. Generative art is also seen as a step toward AI and can help digital artists understand more about how AI works while learning about programming languages like Python and that are used in the production of AI. The use of PBR in this study can stimulate readers' understanding and interest in learning more about the characteristics of generative art and benefits of this new branch of art technology. Future direction. The future of generative arts is undeniably bright as the integration of AI and machine learning opens up to exciting new possibilities. As technology continues to advance, we can expect algorithms to create more refined and nuanced works of art. AI-driven tools will enable artists to enhance their creative processes and provide them with a wide range of tools for experimentation and also inspiration. That's all for today. Thank you very much for your time.